Hello everyone, my name is Peter-Elvis Kanang, and I'm presenting the study of the role of symbolic representation in category learning. Symbolic learning plays a significant role in the way human beings acquire knowledge. The onset of symbolic representation may have expanded our intellectual capabilities and led to the development of culture and tradition. Even though language is important to symbolic representation in humans, symbolic representation does not seem to be an exclusive human property. Non-human primates seem to categorize things using rule-like processes without language. It is thought that this occurs because an explicit declarative learning system facilitates the ability to generate and test hypotheses about salient dimensions for category membership. This requires the recognition of a rule, holding it in working memory, and using it to classify other objects. Symbols may play an important role in these processes. And so the purpose of the present study was to find out whether learning visual symbols could aid humans' attention to salient dimensions and whether these symbols could help categorization. 40 undergraduate students took part in the study. They completed 12 categorization tasks online. Each task had 32 trials, with participants deciding whether the stimuli were ones or twos defined by a color or shape rule. Symbols were always present for all the first 4 training tasks, allowing participants to learn what dimensions the symbols referred to. In the last 8 critical tasks, symbols were only present half of the time. Participants learned to categorize the stimuli in each task through trial and error with feedback. We see under design 4 examples of the tasks. The first is a shape rule task with no symbol. The second, a color rule task with no symbol. And the third and the fourth, color rule and shape rule tasks with symbols respectively. The results. Although performance was very good in all the tasks, the results also showed that performance was significantly better when symbols were present, with a p-value of 0.037 and a partial eta square of 0.152. Pairwise comparisons showed that performance was significantly better when symbols were present in both the shape rule tasks with a p-value of 0.018 and the color rule tasks with a p-value of 0.033. Thus, as expected, participants were significantly more accurate when symbols were present in categorization tasks than when there were no symbols. This research shows that humans can quickly learn symbols and use them to aid category learning. Thus, symbols can play an important role in rule-based categorization. I'd like to end by thanking you all for your kind attention and to also thank all the researchers and assistants at the Complex Cognition Laboratory.